It seems like we've been on this chapter forever, so it might be good just to go through a quick run through of everything we learned this chapter. I noticed that these first 4 things were all things you might have taken notes on in your packet on page 18. So you might want to check there. Classifying triangles by sides and angles. By sides, we could say scalene if none of the sides are congruent, isosceles if 2 sides are congruent, and equilateral if all sides are congruent. By angles, we've got the types of angles, helps me remember this. We've got acute triangles, right triangles, obtuse triangles, and equiangular. Remember that for right and obtuse, you only have to have one right angle or one obtuse angle. And then for equiangular, do you remember what all 3 angles have to measure? 60 degrees each. The triangle sum theorem just says that those 3 interior angles add up to 180 degrees. And the exterior angle theorem is where if you extend one of the sides, and we call that an exterior angle, maybe I'll call it X for exterior, the exterior angle's measure is equal to the 2 interior angle measures that are not adjacent. So that would be this one and this one. So the A and the B measures would add up to equal this exterior angle measure. That's the exterior angle theorem. And the corollary to the triangle sum theorem is only for right triangles. And it basically says if you've already used up 90 degrees, then your other 2 angles have to be complementary. They would have to add up to 90 degrees in order to get that total of 180. The third angles theorem said that if I have 1 set of congruent angles, 2 sets of congruent angles on 2 triangles, then, the punchline is, then that third angle must be congruent to the third angle of the other triangle. We didn't really talk about properties of congruent triangles this time around, but it basically just says that triangle ABC is congruent to triangle ABC by the reflexive property of triangles. And same thing with symmetric and transitive, just that we can use those things with congruent triangles as well. Maybe for the SSS, SAS, HL, ASA, and AAS, you just want to draw those pictures, but also remembering that all of those are reasons that we use to say that triangles are congruent. You have these in your packet already, but just look at the back side of the front cover where we have side, 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 congruence postulate, and side, angle, side, where the angle has to be the included angle between those 2 congruent sides. Remember that HL only works for right triangles, so I'd have to have the hypotenuses and one of the legs marked congruent. Angle, side, angle. I'd have to have that side marked congruent that's between the 2 angles, where angle, angle, side would have a side that's not between the angles marked congruent. Again, those 5 reasons are the only reasons we ever use to say that triangles are congruent in a proof. And sometimes we like to follow one of those triangles are congruent by corresponding parts of congruent triangles are congruent, which basically just says if you have congruent triangles, then all their corresponding parts are congruent. So I could really pick any of the 3 sides or any of the 3 corresponding angles. Let's just grab one, maybe the C and the F. We could say for sure angle C would have to be congruent to angle F if we already knew that those triangles were congruent. And the reason would be CPCTC. For these 2 theorems, base angles and converse, you already have this picture drawn, hopefully. Base angle says if you have an isosceles triangle, then those base angles are congruent. And the converse says if you have a triangle with 2 congruent angles, then it must be isosceles. And these last 2 we didn't talk about the titles very much, but it's kind of the same idea but for equilateral triangles. If you have an equilateral triangle, then you know all the angles are congruent. And if you have an equiangular triangle, then you know all the sides are congruent. I think I mentioned most of these things as we were going through, but maybe just to review the isosceles triangle parts. The two sides that are congruent are called the legs, and the other side is called the base. And then the base angles are those two angles that are opposite the legs, and the vertex angle is the one at the top. The word corollary just means a theorem that goes along with another theorem. For example, these two were corollaries to the base angles and converse theorems because they were like special cases. And the corollary to the triangle sum theorem was just a special case where the angles add up to 180, but in a right triangle, you can just say a little more specifically that those acute angles are complementary. The only other thing I see is that flow proof. That's the type of proof where if I have some givens and it shows me that they lead to some statements, and then eventually, in the end, all of those come together to prove the final thing that I'm trying to prove. That's a flow proof. It's just that same idea, just written in sort of a picture form.